Alright, on number 4, we're drawing the resonance contributor for Ws02 minus, which really is a very painful way of writing the bicarbonate polyatomic ion. Right above those, I'm writing down the valence electrons, because I'm going to answer this problem by first coming up with just a Lewis structure for the entire molecule. So I have a grand total of, let's see, 6, 12, 18, 22, 23, 24 valence electrons. And that is a polyatomic ion, so I'm going to surround the carbon with the oxygens. And I'm going to put the hydrogen off one of those oxygens. That took care of 2, 4, 6, 8 electrons. 10, 12, 14, 16, 18, 20, 22, 24. And that runs out of electrons. If I were to figure out formal charges right now, I have 6 valence electrons on an oxygen minus the 6 dots and the 1 bond would give me a -1 for both those oxygens. For this carbon, 4 valence electrons minus 3 bonds is a +1, and then both of those are 0 because they're drawn like we normally see them. Alright, don't like to have negatives next to positives, and this carbon can actually still make more bonds, so I'm going to take 2 of those electrons on one of those oxygens and actually share it. And that gets our formal charges to 0 for that location and 0 for the carbon. Alright, that's an acceptable Lewis structure. When it talks about the resonance contributors, what we're looking at is just the fact that I could have actually had that double bond form down here. So I actually have 2 resonance contributors for this structure. One where I'll leave the oxygen I did over here with a single bond, and make the double bond form down here instead. So it's just a resonance structure like thing that we introduced in General Chemistry 1 and 2 in Intro. Here, when we talk about resonance contributors, we're just looking at one of those type of things. And we got a -1 on that oxygen for a formal charge.